Our next speaker is from Intel. It's a talk called Transforming Storage with Innovation and Non-Volatile Memory. The speaker will be Bill Lasinski. Bill Lasinski is a Vice President of Strategic Planning, Marketing, and Business Development in the Non-Volatile Memory Solutions Group at Intel. That was a mouthful. Let me say it again. He's Vice President of Strategic Planning, Marketing, and Business Development in the Non-Volatile Memory Solutions Group at Intel. Got that memorized? What does it mean? It means that he drives the SSD group's strategy, product direction, and manages their product planning and marketing, and is responsible for key external relationships. He's a 25-year Intel veteran, a Texas A&M BSEE, and he has also worked on SoC definition and solutions, intellectual property planning, development, and consumer electronics issues. Those are pretty good accomplishments for an Aggie. On a personal note, Bill has a strong passion for music that he expresses through electric guitar, which he has unfortunately burned in yesterday's fire. While he was at Texas, actually that could be the cause of the fire. He was doing some pretty hot licks. While he was at Texas A&M, he was actually responsible for a radio show called Mr. Turtle's Happy Hour on the student radio station, where he performed as a DJ. So let's hear it for Bill. Hopefully he hasn't been too offended by all this.
Wow. Thank you, Jim. I did not see the whole fire thing coming in our discussion, but anyway, good morning. I realize that our little session here is going to be what's stopping you guys from getting to lunch, so I promise we'll try to be energetic and have some fun this morning. Scott, where's Scott Sodoma? He was going to move this for me. Okay, but so I'll just stay over here and not knock this over. Oh, he's going to move it now. Okay, so pay no attention to the tall man in the corner of the stage. Let's see if you can figure out how to do this. Okay, today I'm going to talk about transforming storage in the data center, and he's very good at this. He practiced this last night for us. As we think about what's happening in the data center, there's a flood of storage. We've talked a little bit about this, or you've heard other people talk about this over the last couple days, and it's absolutely true. While this flood of data is happening, it's creating all kinds of opportunities for innovative solutions, and so we're trying to empower those. In early July, Intel introduced the Xeon Scalable Processor family, which is a whole new class of data center CPUs and platforms that go along with it. And that's really designed to help unleash and enable a whole lot of innovation of new services, new capabilities, new ideas in the data center. Obviously, non-volatile memory plays a critical role as part of that, and we'll talk a little bit more. In fact, that's mostly what I will focus on today. The other thing that we talked about, though, is to pull it all together is rack scale design. And rack scale design is about how do we manage things efficiently at scale. So we'll talk a little bit about that as well this morning. This is what we call the data sphere. And the idea here is that data would like to be near the CPU, right? Moore's law is giving us more cores, more performance, more capabilities with every new lithography generation. And ideally, all of that data that we want to process would be directly on the CPU. Obviously, that's not possible. And in fact, we have 3 levels of caching just on our CPUs. And for a long time, DRAM and hard drives gave us the ability to move data around in and out of DRAM, move it in and out of the CPU, and process it and get the results that we wanted. And hard drives, while very slow, were cost effective. But as Moore's law has continued and platforms have gotten bigger and there's more data being created, that model isn't working for us anymore, and it's driving a lot of tiering of data, right? So the idea of hot data that you're actively working right now, warm data, which is data that you need to process or isn't being touched today, but you're not ready to retire it, and then the idea of cold data, right? So as all of these devices get connected, they're generating terabytes of data, and that's creating all kinds of challenges and strains in the data center. So at Intel, looking at this, knowing what was happening, we really wanted to evolve our technology and make sure that we're developing capabilities for the data center of the future, something that could address the data sphere. So in fact, when you look at what we're doing in memory and storage, we're investing in 2 fundamental technologies, and we're going to talk about them both today. The first is 3D NAND. And 3D NAND is all about high density and getting to low cost so that we can displace more hard drives in the data center. And I'll show you what we're doing in that space. Right? The other technology that we're developing is Optane. We introduced this earlier this year, and 3D XPoint is the fundamental media that underlies our Optane technology. Right? And you'll see 3D XPoint manifest itself in the data center in a couple ways. First, as high-performance SSDs, and we'll show you and talk about that this morning. And in the future, you'll see it manifest itself as persistent memory directly connected to the CPU. I won't cover that in detail today, but our server team has certainly discussed it and is moving forward with that technology. So if you think about what's happening in the data center and the move to huge amounts of hot, warm, and cold data, we really need to do something different than what we've been doing all these years to really efficiently run the data center of the future. And for Intel, earlier this year, we introduced the first Optane SSDs. And again, the Optane SSD is really about high performance, low latency, and keeping that data close to the CPU so that you can get very effective use out of all those cores that you're getting because of Moore's Law. And in fact, it really has kind of 4 key benefits when we think about our Optane SSDs. The first is that it offers breakthrough performance, a high degree of IOPS. And in fact, at low Q depths, an Optane SSD is 5 to 8 times faster than a 3D NAND SSD. It also offers very fast or high predictable service. So think of this as quality of service. At 99%, it's up to 60 times, has up to 60, wow, holy cow. It's up to 60x better at 99% QoS efficiency versus what we can do with 3D NAND SSD. The other piece is that it's very responsive under load. And the idea here is that as the drive gets busy and there's a lot of reading and writing, the drive performance doesn't degrade. And then kind of the fourth attribute that's really important for Optane SSDs is that it's very, very high endurance, right? Not a half a drive write, not a drive write, not 10 drive writes, but 30 drive writes a day. And we have found a lot of customers that are very interested in this kind of a capability. And at Intel, I could show you a whole bunch of different charts and talk about the capabilities of the drive. But I found it's much more effective to talk about what our customers are doing with the technology and how they're using their technology, or our technology, in their solutions to create better life solutions. So in fact, why don't we hear from some of our customers?
Technicolor is working on content that push the boundaries of immersive media. Processing power allows us to push the boundaries both photorealistically as well as in workflow.
When we designed the Intel Xeon scalable processors, we really were looking across compute, storage, and network and thinking about what types of innovation we could add that would accelerate performance. We're adding in the Intel Optane SSDs, which we think will deliver another step function in performance improvement.
From the creation of the content, to the rendering of the content, to the processing of the content, it moved things faster than we've ever seen before.
We collaborate with a medical foundation called Imago 7, doing research on MRI, especially in degenerative diseases of brain. Now a researcher in there came up with the idea of undersampling, so getting less data from the machine and filling the gaps by using pre-computed tables. This approach is effective as long as you have a lot of memory, but actually current system does not allow the right amount of memory. So we try to expand this memory using Intel Optane technology.
We started deploying SSD drives and NVMe drives. And at last, we decided to install Intel Optane drives in our scientific computing environment. The Intel Optane drives have low latency and fast speed, and we reached a lot of improvement in our scientific computation.
You can shrink down to 2 minutes examination process that took 40 minutes before, so this is really good for patients.
So I think that was very interesting from a standpoint of if you looked at the last video and watched that, he talked about how by using Optane technology in their systems, they were able to take an MRI from 40 minutes to 2 minutes. Right? If you're a patient, that can be life-changing in the sense that there's a lot of people that are claustrophobic and cannot be in an MRI machine for 40 minutes to have that assessment done. It's essentially changing for those people that might not get an MRI to being able to get an MRI and find out what's going on with them. So it's a huge change in the patient experience just by adding Optane into their solutions. The other piece, though, if you think about it from a business standpoint of, if a machine has gone from running 40 minutes to 2 minutes, you now have a machine that is much more efficient, you can afford to put more patients, your costs come down, and now you can potentially deploy MRI machines in places where you never could afford to do them before. So we're super excited to have customers that have figured out how to use Optane technology. And in fact, on Monday, we hosted a webinar where we took and showed a bunch of different examples of people using Optane technology in their solutions. So if you go to intel.com, you can find that webinar and see a whole bunch of other examples similar to this, where people are taking advantage of Optane technology to build new solutions. What I'd like to do now is talk a little bit beyond 3D XPoint and Optane and come back to our second major technology, which is 3D NAND. As I mentioned, it's the other key development, and it's all about high density and low cost. And in fact, Intel's been investing in a whole series of new products this year to bring 3D NAND to the market. In the spring, we introduced our next generation PCIe product. Last week, this week, we introduced a new family of serial ATA products, and today I'm going to talk a little bit about what we're doing in the dual port PCIe space. So at Intel, we think that we should be building solutions for companies that are at all different phases of kind of their journey and evolution of their data center. There's a lot of customers that are using hard drives, but are ready to move to SATA SSDs. So we introduced a new family of products this week to address their needs. There's a whole bunch of people that have been using SATA SSDs and seeing huge improvements, but they're upgrading their server and networking infrastructure, and they're ready to move to PCIe. So we have products for that. And as I also mentioned, the move from the move from dual port and SAS and high availability is now moving to dual ported PCIe as well. This is something that's been coming for a long time, and we're very excited to see it finally happening. And in fact, we think we're introducing the world's most advanced dual port portfolio of products. Yeah, let me do that. And so let me talk a little bit more about that. As I mentioned, we're introducing these new products, and our 3D NAND-based dual port products are shipping now, and we will be shipping Optane-based dual ported products by the end of this year. So a huge range of product family addressing from something like a high-performance caching tier with Optane to high availability storage with NAND SSDs. So investing across the spectrum in products. Again, talking a little bit about customers that are interested in using our products, what you can see here are some quotes from different customers that are actually using our dual port technology. E8 and Combinario are storage startups that are doing some very interesting things with our dual port products. Dell EMC is interested in our dual ported Optane solutions, and the stock exchange in Tel Aviv is very interested in moving to dual port because they want that high availability capability, the up to 6x improvement of performance of having dual port PCIe versus SAS, and making sure that they are very efficiently running their exchange. So in addition to these customers that are actually using the technology and seeing real advantage, we also have an ecosystem set of partners that we've been working with that continues to grow that are building dual-ported PCIe infrastructure. So again, as we move to faster media of 3D NAND and things like Optane, we need to be upgrading our overall infrastructure. SATA and SAS have been great, but their software overhead and their overall latency will not allow these new media to shine, and again, unbalance the data center when you're adding all these new performance capabilities through your CPUs. So this move to dual port PCIe we think is absolutely critical to how the data center is going to evolve. Okay, the next thing that I'd like to talk a little bit about is something we call volume management device. And this is about driving an efficiency at scale and talking about things that you might see in a cloud-based solution. When we worked with the server group at Intel, as I talked about, they introduced the Xeon Scalable platform in July. One of the capabilities that we added was volume management device. And this is a capability that allows you to plug storage devices directly into the CPU off the PCI route. So VMD creates an isolation on the CPU that allows you to have LED management, have great performance. So I have those SSDs directly connected to the CPU, but they're also hot pluggable, something that really wasn't capable or wasn't easily done in the past. So VMD is on all these new platforms. So again, we're moving data closer to the CPU and allowing you to do things that you couldn't do before in a highly managed and an efficient way. And one of the things that I think is very interesting about VMD was this conversation actually started 4 years ago when the Xeon Scalable family was still in the planning phase. Folks in NSG, our storage and memory group, actually engaged with the server group to get this capability built in to make sure that we would have this capability when the platforms came out. And I think it shows why people want to use Intel building blocks and why we have a lot of partners that work with us, is not every company can think 4 years in advance and think about what the data center future is going to look like, and then actually make the investments to make those products a reality or those capabilities a reality. And in fact, we didn't really stop there. Building on VMD, which is a great capability, we have been innovating in our soft RAID, or what we call VROC, the virtual RAID on CPU. And the idea here is if I have large amounts of high-performance storage directly connected to the CPU, I should be able to boot from it and have RAID functionality. And in fact, that's exactly what VROC offers and what it does. And it offers a huge increase in performance over running just a standard RAID card or something that's been on a previous legacy system. And if you're not using a RAID card, you can save power and actually apply that savings to somewhere else in the system. So we like to think about this as building a complete solution and a highly optimized solution for cloud-based services. Okay. One of the other things that I'd like to touch on this morning is the ruler form factor. And I'm surprised, the name, how we got the name is very funny. And actually not very complicated. It's because it looks like a ruler, right? A lot of you, if you were in school, had something in your desk that looked just like this. But the idea behind the ruler was, up until now, all the storage devices in servers had been based on having hard drives in the system. And they weren't really optimized for solid-state media. The cooling wasn't optimized, the layout wasn't optimized, and you certainly couldn't maximize the capacity of the device. And so the ruler started out 2 years ago as a project that we called the tub of NAND. And the idea behind the tub of NAND was how much NAND, how much storage could we put in one rack unit of area in a server room. And it evolved from literally just a box of NAND into what became the ruler. And the ruler is very exciting for a few reasons. One, it's serviceable and uses PCIe as the interface. But it's also 55% more efficient than U.2 as far as cooling. And while we had a lot of great concepts and we did a lot of work internally on this, we realized that we wanted the industry to be able to take advantage of this. So we formed a work group called EDSFF. Hopefully you guys, a lot of SFFs going around here at the show. EDSFF stands for Enterprise and Data Center Small Form Factor. And hopefully you guys were able to attend the session yesterday that the team presented talking about this. But the idea is that we can turn this into a standard, and the group has pretty much standardized the connector, and they're working on the form factor standardization. And they did a great job in the sense that this connector is ready for PCIe Gen 3, for PCIe Gen 4, and PCIe Gen 5. So they've done a lot of future proofing on this connector, and they've been thinking about how do we make sure that while we're designing the data center of the future, we're building the right building blocks. In fact, the other thing that's become interesting about this is, while this is a great storage device, doesn't have to be just a storage device. So we've had a lot of interest from people that are building accelerators, and the idea is that they can now build accelerators in this form factor, and you now have high-density storage, high-density accelerators, all with compute in one small platform. And in fact, let me kind of visually show you what that might look like. This is a rack, right? 42U in height. And I was talking about how we wanted to build a petabyte of storage into one rack unit, right? Or how the ruler was very, very high density. And you can imagine that this is 1 petabyte of storage with 2 terabyte hard drives. And it's heavy, it uses a lot of power, and you have to design a data center to hold all these kinds of racks. But what we're going to be doing going forward is with the ruler, you can now put all of this in one U. So with 32 terabytes on a ruler, you can put 32 of them across the front of a 1U box and have a petabyte of storage in 1U. So you can build a hugely dense, set a flash. And you could also say, well, wait, I don't need to just use flash. I could also take some of these out and put in Optane rulers, which we're also going to build. And I can now build a hyperconverged system that has a caching tier based on Optane and a storage tier based on NAND. So a lot of exciting things that we can do with the ruler form factor. As I mentioned, you can also do accelerators. So we think this is really going to fundamentally change the data center, because if I don't have racks, 42U to get to a petabyte, but I can do it all in 1U, my CapEx and OpEx ratio have fundamentally changed, right? I don't have as much power, I don't have as much weight. I can now put huge amounts of storage at the edge or locations where I couldn't afford to put a data center. And my OpEx goes down because I don't have all those operational costs associated with a lot of electricity, a lot of extra cooling. So we think the ruler and the work that we're doing with our partners is really going to fundamentally change how data centers are built. But once again, I don't want to just talk about things that we're thinking about. What I'd like to do is bring a customer out who can talk about how they're taking advantage of some of our technologies. So what I'd like to do now is ask John Considine, who's an IBM Vice President and General Manager of Cloud Infrastructure, come on out and he can talk about what they've been working on with us. John? He's lost back there. There he is.
No music? Come on.
Sorry. And I didn't bring a guitar. Hey, John, thank you for being here today. I appreciate you taking time out of your busy schedule. Would you talk a little bit about what you guys have been working on with us?
Sure.
And what you've been doing?
Yeah, absolutely. Look, so at IBM, at our cloud infrastructure and what we deliver for our customers, we really believe that data is primarily important for our customers. It is one of the most valuable assets an enterprise has. And so we've set about building a global scale cloud platform that protects that data, delivers the services so that it can run applications, blockchain, analytics, and of course the big one for us is the cognitive infrastructure. And we've been growing this platform pretty dramatically. Our cloud platform now is 55 data centers across 19 countries.
Wow, big footprint.
Distributed all over the world, and we continue to grow it. And to grow it, we really need some great partnerships. So I'm a lot more than a customer. We're really a big partner with Intel. And some of the things that we've done over the last 12 months, working really close with you on some of these technologies, but broader than that. We announced in March our secure virtualization service. It's really a first of a offering and a number of security capabilities that we're delivering. In July, we announced our cloud servers based on Skylake. I know you've got a big long name.
Xeon Scalable.
Xeon Scalable. All right, so on Skylake, got it. And just last week, we actually announced the availability of the Optane SSDs in our cloud servers. So now you can get cloud servers with that kind of technology.
Yeah. Hey, John, you guys have been working close with us on rulers, as you said, and you've been deployed these for about 8 months. Can you talk about some of your experience today?
So let me tell you about that. I mean, you kind of picked up about what happens with density and manageability, but look, here's the problem for us. We are a global scale cloud provider. And when we look at what's happening in the market around analytics, around IoT, this kind of deluge of data, in the cloud, we've really had to go after the fundamentals of storage, okay? How we get there, how we operate on it, because as we increase our work on the cognitive front, the training models, all of that, we've really had to get to a situation where we can build vast quantities of storage with very high-speed access, low latency, to be able to serve those markets. And so, look, we looked at a lot of ways of doing this. We use a lot of different things. We've done a ton of work with with this ruler form factor. We love it in terms of its density, its serviceability, its endurance. To give you an idea of where we're at with it, it's early days, but we've been working with some other partners on here, Dell's Extreme Scale Infrastructure Group, to build a storage sled that is loaded with those rulers.
Yes, absolutely.
To give you an idea of that, that box right now is doing 3 million 4K IOs a second out of that box. It's connected with some other works we've done in partnerships with our Red Rock Canyon fabric. We've done a mesh fabric, and I saw in some of the other presentations here today that the idea of putting flash and storage on a fabric happens to be a pretty popular idea.
Yes, absolutely.
We're very far down that road. So right now we're doing more than 3 million IOs per second out of one sled within our infrastructure. Now imagine that we have hundreds and thousands of these sleds in there. Big deal. And we believe that with this technology and the advanced work we're doing, we'll probably get up to about 5.8 million IOs per second.
That's awesome. That's awesome. Hey, John, you mentioned the Optane thing a little bit. Can you say a little bit more? Like we did the test bed earlier this year. And
Yeah. So we announced the Optane test bed last year. And it was really in a partnership with you. Something that we're really kind of excited about in the cloud is working with partners, bringing this technology to a place where you can actually access it. So we built this test bed in conjunction with Intel here. We had 50 customers come in and use that test beds. These are tier 1 ISVs, universities, enterprises, right? Businesses. Turns out to be important. They pay the bills. And IBM properties as well to come use that. And really some dramatic results. We have some work where we use the Optane to accelerate a key value store application. We got more than a 10x improvement.
Wow, that's great.
That. And then one last one is working with VMware, doing a flash vSAN deployment using the Optane in there. We got about a 40% increase in performance.
Okay.
Really powerful solutions.
Awesome. Hey, John, thank you for coming out.
All right.
Thank you for the great partnership and all the sharing what you guys have been doing with our technology.
Perfect.
I appreciate you
Thanks,
making the
Bill.
trip. Thank you.
Thanks.
Okay, so what we tried to cover today was a range of things, right? There's a huge amount of data that's being created by all these connected devices, and that data is coming to the data center. It needs to be managed, processed, stored, et cetera. And the data centers that we've had up until now really won't be able to deal with that flood of data in an efficient way. So technology needs to evolve. So Intel's invested in things like the Xeon scalable processors, and we're investing in 2 non-volatile memory technologies. 3D NAND, that's all about high density and low cost, and 3D XPoint, our Optane technology, which is all about high performance and low latency. And we're offering those building blocks in innovative form factors like this, and you heard how customers are using things like the ruler, things like Optane technology to offer new solutions to the marketplace, either to improve things like the MRI, or to offer services and capabilities that just simply weren't possible before. John talked about some of the things that they've been doing that are new services and capabilities. So we're very excited about this. We're very excited about the data center of the future, and in fact, we think we're helping all of you create the data center of the future today. So hopefully, you'll join in partnership with us and have a great business opportunity. So thank you for being here. Thank you.